Welcome to the CompTIA A+ Prepcast presented by baremetalcyber.com. Understanding the life cycle of an operating system is a critical part of both system planning and day-to-day support. The life cycle defines how long a given version of an operating system will receive updates, including feature enhancements, bug fixes, and security patches. As an operating system ages, support from the vendor eventually ends. This affects compatibility, stability, and overall security posture. The A+ Core 2 exam includes questions about OS lifecycle stages, how to plan around end-of-life systems, and what risks are involved when using outdated platforms. The life cycle of an operating system is generally broken down into three main phases. The first phase is called mainstream support. During this phase, the vendor releases regular updates that include both new features and bug fixes. The second phase is called extended support. During extended support, the vendor releases only critical security updates, no new features or major changes. The final phase is end of life. Once an operating system reaches this phase, it receives no updates or support. This makes the system increasingly vulnerable to security threats and compatibility issues. Windows operating systems have well-defined life cycles, but the details vary by version and edition. For example, Windows 10 includes different end-of-life dates for each individual feature update. Home and Pro editions often reach end of support earlier than Enterprise or Education editions. With the release of Windows 11, Microsoft introduced hardware-based requirements like TPM 2.0 and Secure Boot. These requirements may block upgrades on otherwise functional systems. Technicians must review both the operating system version and the hardware profile before planning an upgrade. Apple takes a different approach with macOS. Instead of a published end-of-life schedule, Apple typically supports the last 3 or 4 major macOS versions at any given time. Updates are frequent and usually delivered with minimal disruption. However, Apple sometimes blocks older hardware from receiving updates, even if the device is still functioning well. This means some Mac systems fall out of support sooner than expected. Technicians must check the model year and hardware compatibility list for each new macOS release. Linux distributions each have their own lifecycle policies. Ubuntu, for example, offers LTS versions or long-term support releases every 2 years. These are supported for 5 years. Other distributions use a rolling release model, where updates are delivered continuously and there is no defined end of life. Once a Linux distribution reaches its end of support, package updates and security patches stop, which can lead to vulnerabilities and compatibility failures. Choosing the right Linux version depends on the use case and the organization's tolerance for change. Operating system upgrades can introduce compatibility concerns that affect software, drivers, and hardware behavior. Older applications may not run on a newer system due to missing libraries or interface changes. Some hardware components may lack drivers for the new version. Changes in the file system or security model may block older tools from functioning. As a result, upgrades are sometimes blocked by the system until certain issues are resolved. The A+ exam includes scenarios where a technician must identify or resolve upgrade blocking factors. To check system compatibility before an upgrade, each platform offers different tools. For Windows, the PC Health Check tool reviews system specifications and alerts users if requirements are not met. For Linux, booting into a live environment lets users test hardware support without installing. On macOS, compatibility depends on the model year and hardware configuration, which can be checked on Apple's support site. Using these tools prevents failed installations and helps technicians prepare properly for each upgrade. Software compatibility is another concern when upgrading an operating system. Some legacy applications were written for older platforms and do not support new APIs or system behavior. In Windows, compatibility mode allows applications to run in an environment that mimics older versions. In other cases, virtual machines are used to isolate older software on a current system. Testing in a sandbox or pilot environment before deployment helps identify which applications will continue to work and which need updates or replacements. Continuing to use an unsupported operating system introduces serious risks. Without security patches, vulnerabilities remain open to exploitation by malware or attackers. Antivirus tools may stop supporting the outdated OS. Vendors will likely stop offering technical support or driver updates, leaving the system unpatched and unprotected. In regulated environments, using an end-of-life system may violate compliance policies or industry requirements. For these reasons, technicians must prioritize migrating away from unsupported systems to maintain a secure and functional environment. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. Planning an operating system upgrade is a structured process that begins with inventory. First, you must review all devices on the network and assess whether they meet the hardware and software requirements of the new operating system. Compatibility tools help identify systems that are ready or blocked. Next, you back up all critical data to ensure recovery in case the upgrade fails. Once confirmed, the upgrade is scheduled during low-impact hours, such as overnight or on weekends. This reduces the chance of disrupting users during business operations. Understanding version numbers and build identifiers helps track changes between and within operating system versions. Windows identifies its operating systems with major version numbers and build numbers. For example, Windows 10 build 19044 differs significantly from build 21H2. Linux distributions track kernel versions and package sets, which determine what drivers and software are included. Mac OS uses a version name and number, such as Ventura 13.5. Being able to identify and compare these versions is useful when troubleshooting or planning upgrades. Hardware requirements can block operating system upgrades, especially as systems age. Windows 11 requires TPM version 2.0, secure boot, and supported processors. Devices without these features cannot upgrade without unsupported workarounds. Newer versions of Mac OS are designed to run on Apple Silicon, such as the M1 and M2 chips, and may exclude Intel-based Macs from future updates. Linux is more flexible but may need proprietary drivers for wireless cards, video chips, or printers. Technicians must confirm hardware support before attempting upgrades. Software compatibility testing is essential before rolling out a new operating system. This involves running test versions of the new OS on pilot machines, using virtual machines, or sandbox environments to simulate production use. Technicians install critical software, verify driver compatibility, and monitor behavior during testing. Any failures are documented and reported before the main upgrade occurs. This step prevents widespread disruption, especially in environments where downtime affects productivity or revenue. Downgrade paths are not always available or easy to use. While upgrading an operating system can often be done in place, rolling back requires preparation. If the system was not backed up or if an image was not captured, reverting may involve reinstalling the old operating system from scratch. Some operating systems, like Windows, offer a limited rollback window, usually 10 days after an upgrade. Licensing can also block downgrades, especially when moving from a consumer edition to an enterprise version. Downgrade planning must be considered in every migration project. Here is a practical scenario. After upgrading several systems, a technician discovers that a legacy accounting tool fails to launch. The application vendor no longer exists, and no updated version is available. Rather than halting the upgrade for all machines, the technician isolates the few affected devices and runs the legacy software in a virtual machine running the older OS. This compromise ensures the business can continue operating while still progressing toward modern system adoption. Driver compatibility is another key concern. Graphics drivers, printer software, and chipset utilities often break during major operating system transitions. If the vendor does not support the new OS, the hardware may become unusable. Technicians should check vendor websites for updated drivers before upgrading. Tools like Intel Driver and Support Assistant, NVIDIA GeForce Experience, or manufacturer-specific utilities help verify compatibility and automate updates. Never assume that built-in OS drivers will provide full-feature support for specialized hardware. Long-term support versions, often called LTS editions, are important in business and regulated environments. These releases are designed to remain stable and receive updates for extended periods, typically 3 to 5 years. They are preferred in financial, healthcare, and industrial systems where reliability and security are more important than cutting-edge features. Ubuntu offers LTS releases every 2 years. Windows also offers Enterprise and Education editions with longer support timelines. Technicians must know when LTS is appropriate and how it fits into an organization's support strategy. Compliance and audits often drive OS upgrade decisions. Some industries require systems to remain on supported platforms to comply with regulations such as HIPAA, PCI, or GDPR. When an operating system reaches end of support, organizations may be forced to upgrade to avoid legal or operational penalties. Lifecycle calendars help plan ahead by showing when specific versions will lose support. Aligning upgrade plans with audit schedules ensures continuous compliance and prevents last-minute scrambles. To summarize, every operating system has a lifecycle that includes release, mainstream support, extended support, and eventual retirement. Technicians must plan upgrades carefully, test for compatibility, and ensure systems remain supported for security and compliance. Using the right tools, documenting requirements, and preparing for potential failures are essential tasks. The A+ exam will challenge you to identify support phases, resolve compatibility issues, and recommend appropriate upgrade paths based on real-world scenarios. Thank you for listening. Please visit baremetalcyber.com for more cybersecurity information, podcasts, books, and more.